Okay, my notes indicate that we got through question 15 last time. So why don't we pick up with 16? And this is the section on ratios and proportions.
Okay. Okay, on this one, it's just straightforward solve it.
Okay.
So I don't start with multiplying both sides by 11, or we can, yeah, both sides by 11 or cross multiplying.
Okay. Let's cross multiply it. That's two steps in one, kind of.
Okay, so you end up with 33x minus 11 equals 25x plus 125.
Okay. What's the next line?
Add 11 to both sides and deduct 25x, or not to both sides, but to the other side, and then deduct 25x from 33x.
Okay.
And then divide both sides by 8.
Must
X
be
equals 17.
Must be 17, since I saw only one tens digit of 1. Okay, 17. Oops, hold on a second.
These I definitely need help with.
All right, these are work problems, W-O-R-K. And it's funny, I worked with this guy on GMAT for 2.5 years, and I thought I came up with the niftiest way to solve work problems ever. And then on the GRE, I noticed that they always use a technique that I like even more. And most of their work problems can be solved using this technique. So if 4 boys can shovel a driveway in 2 hours and they want to know how many minutes, so let's immediately transfer that to minutes. So 4 boys take 120 minutes. Well, that must mean that there are 480 boy minutes worth of work to do. And now, to find out how many minutes it will take 5 boys to do the job, what would we do?
I don't know.
Well, let's say I had a 16 man-hours worth of work to do. And I had 2 men that could do it. How long would it take them?
Okay, I'm sorry, repeat that?
I have 16 man-hours worth of work that need doing. In other words,
Okay.
it would take 1 man 16 hours.
Uh-huh.
If I have 2 men working, how many hours is it going to take to get those 16 man-hours worth of work done?
I'm assuming 8.
Right. In other words, the process is divide. And notice that if you divide 16 man-hours by 2 man, the mans cancel and you're left with the units that you're looking for. How many hours does it take? Okay. So if we have 5 boys doing a job that takes 480 boy minutes to do, the boys will cancel. We'll end up with the number of minutes that it will take those 5 boys to do the job.
You know what, if you're writing this down, I'm not seeing it.
Oh, yes, I am. Wow, I had no idea. Thanks for telling me that. Let's see, I'm showing my screen. Let me turn my camera off. Maybe that'll help. Can you see this white board here?
No.
You can't see that. Let me close it and open up another one. Can you see the problems?
I can see the problems.
Okay. Huh. Not sure I've ever had that happen. You can see it now?
Now I can see it.
Okay. Yeah, by all means. I always have this on display, so let me know if you don't see it sometimes.
Okay.
Okay. But what we had was 480 boy minutes worth of work to do. So if we divide that by 5 boys, we're left with, and I can approximate that, it doesn't quite go in 100 times, so it must be 96. 96 minutes. Okay?
I'm not, let's see, so 4 boys, how come we're at 480?
Well, because it was actually 8 boy hours worth of work.
Okay.
Because it took 4 boys 2 hours. So we converted the 2 hours to minutes, 120 minutes. So we actually had 480 boy minutes worth of work to do.
Got it. Okay.
Divide by 5 boys, you get how long it'll take to do that job. Similar kind of question, not quite the same, but so notice what's similar. They're asking for a week, and they ask how many days. So we definitely are going to have to convert to one or the other. Since they're asking for a number of days, let's convert this week to 7 days.
Okay.
So 500 pounds of mush will feed 20 pigs for 7 days. So that's 140 pig days of food. Well, we only have 200 pounds of mush, so we have 2/5 times 140. And that is 56. So now we have 56 pig days with our 200 pounds of mush. So if we divide 56 pig days of food by the number of pigs that we're having to feed, 14, we have our answer. Let's see if they did that any differently in the book. No, that's exactly how they did it. Again, it's that same concept of boy minutes worth of work or pig days worth of food. In other words, if you have 140 pig days worth of food, you could feed 140 pigs for one day, or you could feed one pig for 140 days.
Okay.
Okay? So then the next step, in other words, that tells us how much, what the rate that the pigs are going to eat. And we know we have 2/5 as much mush because we have 200 pounds compared to 500 pounds. So multiply the 2/5 times the 140, you get 56 pig days worth of food, divide by the number of pigs. So it's a real similar process as the last problem, only it's not really a work problem, but it kind of is. Now, somehow, I'm not sure what happened, but somehow I got skipped ahead 3 or 4 sessions ago, and we did these problems.
I remember that.
Blue marbles. I remember doing the difference between the smallest and largest share. So let's make sure we don't waste more time doing that. Let me pull up the next page. Let's go to averages. That's the next math discipline that they want to talk about is averages. Okay. And remember one thing about averages that I tell every single student I have every time I encounter an average problem. And know that the solution lies in totals. And by that I mean if Michael's average on 4 tests is 80, what must his 4 tests total to be? That's
300.
Right. And that's the thinking you want to begin all average problems. Don't try to compare averages. In other words, don't try to compare the average of 80 with the average of 84. Find totals. Okay, so what should we do with the second sentence on this problem?
84 times 5.
Okay, what's that number?
Which is 420.
Okay.
So 420 minus 320, he needs 100.
Exactly. They become a piece of cake if you work with totals. Number 2 is a little trickier. So work me through the steps.
Okay, once again, total would be 320 for the first.
First 4.
Okay, so multiply 85 by 5, which would be 425.
Okay. Now hold on.
But it can't.
Okay. I think this problem probably works a little bit better if you go to the end before you go to the middle.
Okay.
You know what I'm saying? In other words, let's see what the end means. If she's to get an 85 average after 7 tests, what are her totals going to have to be?
595.
Okay. So what's the lowest score she could have on the 5th test and still total 595 points for the first 7 tests? and she can get no more than 100 on any test.
I'm stumped.
Okay. Well, whatever this fifth test must be, it would have to be 395 afterwards, because she could get 100 on the sixth test and she could get 100 on the seventh test. And in other words, our goal is to be able to get 595. Well, we know we can get 100 and 100 on the last two, so we can get at least 520 even if she got a 0 on the fifth test. But what if she gets a 75 on the fifth test? That would give her totals 1 through 5 tests of 395. And that would still allow her to get a total of 595 after 7 tests. So not only is it helpful to begin at the beginning, and your second step is to look at the ending total, but it might be the only way to get there. In other words, finding this number really is the third step of the problem.
Okay.
Okay? It's difficult to even think about this number until you've done this step here.
I'm not even sure where to start.
Well, this one, believe it or not, is not a total problem. It's one of the few arithmetic means that totals is not the avenue that you go about doing it. It's kind of, it's a back-solving problem is what it is. In other words, can you give me 4 numbers that average 80 where none of them are 80? In other words, let's see if A works. Can I average 80 without having any 80s in there?
No.
Well, how about 79, 81?
Oh.
79, 81. Now, the mathematical way to do totals is to add the 4 numbers and divide by 4. But it's frequently useful to think about them in pairs. I know that is an average of 80, and I know that's an average of 80, and 80 plus 80 averages 80. So that kind of thinking is helpful on a problem like this. So we could definitely do it with 0. Could we do it with 2? Well, clearly I could replace these 2 with 80. So I can do it with 2. Can I do it with 4? I can replace both of those with 80. So the only 2 in question are 1 and 3. It was at this point when I looked at this problem that I realized the answer instantly. You can't do it with exactly 3 80s, which is the easier one to figure out than how to do it with 180. You can do it with 180, but it's going to take probably 15 seconds to figure out the combination. But notice that 380s are impossible because the fourth one has to be 80, and yet it can't. It certainly can't be any number other than 80, not to give you an average of 80. So you can't have 3. Okay, that kind of is more of a counting problem. by a counting problem, I mean laying out the possibilities that you can have. It's the arithmetic average of the numbers 1 through 100 inclusive. In other words, we got this. What is that number going to be?
Wouldn't it be 50?
Very close. The trick here, obviously, is not to add them all up. The trick here is to come up with some sort of a quick way to add them up. Now, there are formulas for adding up arithmetic sums, but I don't want to go into that. I don't think you need to memorize those. However, finding the average between 4 consecutive numbers, or an even consecutive. First of all, let's talk about 5, an odd number of numbers. What's the average between these 5 numbers?
3.
Okay. Now let's talk about the average between an even number of numbers.
We're going to add the 2 and divide the 2 middle ones and divide by 2.
Okay. So it's halfway between the 2 middle numbers. Well, 1 to 100, what are the 2 middle numbers?
50 and 51.
Correct. So what's the answer?
50.5.
All right. Yeah, that's a bit of an obscure number theory problem.
That was a good way to explain that, though.
Well, the way to solve all of these problems that involve lots of stuff is to try to figure it out with little stuff that you can actually manually figure out, and then apply the principle to the larger numbers. All right, if 10A plus 10B, be suspicious immediately, we have the same coefficient. That should be useful. What's the average of A plus B? What are we going to need to figure out the average of A plus B? What would that equal to? If I gave you numbers for A and B and I said, what's the average of them, what would you do?
Multiply by 10 and add them together and then divide by 2?
Well, just finding the average of A and B is A plus B over 2. So this is what we're trying to solve for.
Okay.
And we're given this. Can you solve for A plus B over 2?
Divide by 5? No.
Close. Well, solve for A plus B. What's A plus B equal to?
I don't understand.
Okay. A plus B over 2 is what we're trying to solve for. So let's start by seeing if we can solve for A plus B. Remember when I said note the same coefficients? That's going to make it easy for us to solve for A plus B. I can factor out that 10. Divide both sides by 10. Well, that's a plus b. What's a plus b divided by 2?
3.5 divided by 2.
Yeah. So I don't know if that's the answer you'd want to put down, 3.5 divided by 2. I put down 1.75. Although from what you've said, they would have to accept that. You with me here?
Yeah, I think so, yes.
Okay. All right. In other words, had this been a 9, I cannot solve for a plus b, let alone a plus b over 2. The only thing that allows me to solve for a plus b is the fact that that coefficient can be factored out.
Okay.
And that allows me to solve for a plus b. Once I can solve for a plus b, I can solve for a plus b divided by 2 just by dividing both sides by 2. Okay. This one looks very intimidating. Your first thought might be, well, I got 3 equations and 3 variables. That means you can solve for each variable. Okay? If I want to go through the process of solving 3 equations and 3 variables for each variable, I can do it. Meaning that if I devote enough time for this, I can definitely solve it. But that's a fairly tough process. I don't know if you remember how to do it. You know how to solve 2 equations and 2 variables. You can use elimination. Well, you do the same thing with 3 variables and 3 equations. But say to yourself that it's not likely that they're actually going to force me to go through this huge process to solve for 3 equations and 3 variables. So let's look and see if maybe there isn't a shortcut. We're trying to solve for what? Put this last second sentence or second line here into an expression for me.
X plus Y plus Z divided by 3.
That's what we're looking for. Okay?
What I would do is add the 3 equations.
Beautiful. That's what I was looking for. I was trying to figure out how to get you to tell me that. Because that would be the only shortcut I would be able to think of. Is let's see what happens if we add the 3 equations. We might get something very interesting looking. So what do we get?
We end up with 2x plus 2y plus 2z equals 22.
Notice the same coefficients. Now what?
Well, we can factor out the 2.
Okay.
And then divide by 2. Guess we didn't need to factor that out.
What's that?
I guess we didn't need to factor out the 2.
Well, you're right. We
And
could
then
have just
divide by
divided
3.
everything by 2s, every part of the equation by 2. Would have saved a step, but it's basically the same process. So that's not a big deal. But what's our answer?
Divide by 3, so 11 over 3.
Okay. Just wanted to make sure you didn't fall for the trap answer there, which would have been 11. And they did put it on there. But again, why that worked so pretty was same three coefficients. So
In this case, I would write the equation as 5 plus 6 plus 7 plus W divided by 4 equals 8.
okay, and then solve that for W.
Yes.
Pretty straightforward. How about this one? There's a pentagon. They didn't say regular or anything. What do we need to know to answer their question?
We need to know what the degree measure of all 5 angles.
The total.
Yes.
Exactly. There is a formula for this. I think it's probably worth memorizing, but I'm going to show you two different ways. There's the formula, where n is the number of sides of your shape. In other words, if n in this case is 5, then I have 3 times 180, so I should have total angles of that. Divide that by 5. There's my average.
Oh, okay.
Okay? It's easy to forget this formula. If you think you have the formula memorized, because they may ask you about a nonagon, a 9-shaped figure, in which case you kind of need these formulas. But if you're not sure if you've memorized the formula correctly, apply it to triangles. Notice that we have 3 minus 2 times 180, and we know that's correct for a triangle. Apply it to squares, and we know that would be 4 minus 2 times 180, which is 360. So if the formula that you think you remember correctly works on triangles and squares, then it almost certainly is the correct formula.
Okay.
Okay? But that's it. N minus 2 times 180. Now, as one last way to remember this, take your figure, start from any vertex, and draw it and separate it into triangles. There's 3 triangles. Each one has to have 180 in it. So 180 times 3 would give us the total sum of the angles in that figure.
Oh, that's a good way to do it.
Yeah, either way works as long as you can. The quickest way is that formula, but it's hard to remember that formula if you don't use it very often, and most people don't. Let's see. A plus B equals 3 times C plus D. What's the arithmetic mean of A, B, C, and D? So let's start at the end. What's that expression going to look like?
A plus B plus C plus D divided by 4.
Okay, so that's what we're trying to solve for. Now, the next thing we should do is look at the answers, because they're going to be very telling. All the answers have C and D in them. They don't have A and B anymore. So what should we do here?
Solve for C and D in terms of A and B, although that's already done.
Yeah. Oddly enough, that was my first step also, and that's backwards. The moment I did that in my head, when I looked at these questions this morning before our session, I said, well, C plus D equals A plus B divided by 3, so I could substitute, but then I'll have an answer that's all in terms of A and B. And that's not what I want. I want an answer that's in terms of nothing but C and D. So what do I want to substitute for here? I don't want to substitute for C and D. I want to substitute for A plus B. I want to replace this part of it.
Okay.
Notice that if I just take the equation they give me, distribute it, so instead of writing A plus B, I'm going to write 3C plus 3D for this part here.
Okay.
Plus C plus D all over 4. That's going to be our answer after we simplify it. In other words, the goal is to eliminate the A and the B, not to eliminate the C and the D.
Okay.
So that we end up, and then this simplifies nicely into 4C plus 4D over 4, which is C plus D. Final answer.
Okay.
So in this problem, it was very necessary to look at their answers. In other words, had this not been multiple choice, we would have had a bunch of ways to express it. I could have actually just expressed it like this, although they probably would have said, what does this arithmetic mean in terms of C and D? Or in terms of A and B. Notice that if they wanted the answer in terms of A and B, then I would have substituted for the C plus D part of it. And I would have gotten a bunch of answers in terms of A and B. So
I just hadn't thought about putting the 3C plus 3D into the A plus B. That was good.
yeah. All right. Let's see. Okay, I haven't looked at these yet. L and M are not parallel.
Once again, not sure.
Well, let's first of all talk about parallel lines. I think we have, but let's do it again. If you have two parallel lines and a transversal, you create 8 angles. There's 4 there and there's 4 there.
Okay.
Okay, but you really only create 2 angles. You create a big one and a little one. And every other angle created is either A or B. There's the little one, here's a little one, here's a little one, here's a big one. And what else do we know? We know that A and B are supplementary.
Correct.
That's what you have to know about parallel lines. Okay?
Okay.
If these 2 lines were parallel, what would the average angle be of those 8 angles?
Could be 360. Sorry.
That's okay, no problem. My dog barks so much that there's no way anybody should ever have to apologize to me. Um, how many angles do we have? What's the sum of those four angles?
Oh, and actually that would be 360, wouldn't it?
Yeah. So we're going to have 720 divided by 8, which is the same as 360 divided by 4. Our average angle there is going to be 90 degrees.
Okay.
Okay? Now, let's take two non-parallel angles and a transversal. What's your average angle going to be?
Is it still going to be 360?
Yes. In other words, it doesn't matter if these are parallel or not, because if they're not parallel, these two have to be supplementary and those two have to be supplementary. So you still have to add to 360 there, and same thing there. They have to add to 360. So being parallel doesn't affect the average angle. In other words, whether they're parallel or not, the average angle is the sum of those 8 angles divided by 8, which we know to be 90. So A clearly is not 45. It's also not that. There's our answer right there.
Okay.
Pretty straightforward. The only part of this that's interesting is the fact that they tried to trick us by telling us those lines weren't parallel.
I know, as soon as they did that, I wasn't sure if they were 360, if it was still 360 degrees away.
I wasn't either until I thought about it and I realized, well, those 4 angles still have to add to 360, no matter what. But it shows their devious ways. They definitely are out to trick you.
Oh, they are.
By putting in irrelevant information. Actually, the problem probably would have been a little harder if they didn't say, because then you would have spent some time trying to figure out whether it makes a difference or not. Okay, so what is the arithmetic mean of 2 to the 10th and 2 to the 20th?
Add the exponents. No?
What's the expression that I would write?
I would do 2 to the 10th plus 2 to the 20th divided by 2.
Okay, that's correct. But when you're adding same base, you can't add the exponents. That only works if you're multiplying. If I had 2 to the 10th times 2 to the 20th, then that's equal to 2 to the 30th.
Okay.
But if I'm adding and subtraction always makes things more difficult than multiplication and division. Multiplication and division are a piece of cake, but adding different numbers is a problem. So if we have same base, different exponents being added, let me think about this for a second. Let's see. Let me talk about numbers that I can get a handle on, first of all. If I wanted to do that, that would be 8 plus 16, which is 24. Is there any way to do that quickly? No, for the same reason that we cannot add x squared plus x. There's no way to add x squared plus x. Different exponents, same base, but we're adding them, so that's the best we can do. However, we could factor out a number. What if I factor out a 2 here? And I make this 2 times 1 to the third plus 1 to the fourth. That doesn't work. Let me look at their answers. This is a very, very interesting problem. Notice the difference between 2 to the 10th and 2 to the 20th. It's gigantic.
It is.
So this number is going to rule. And if we merely divide that number by 2, we get 2 to the 19th by subtracting exponents. Now I figured out how to do this problem. Let's break this up into two fractions. That fraction plus this fraction. And you can do that. In other words, a plus b over c is equal to a over c plus b over c. Just do not make this mistake. That is not equal to a over b plus a over c. You see the difference?
Yes.
Okay. So we can only split it into two fractions if our denominator is a single thing. So I'm going to make this 2 to the 10th over 2 plus 2 to the 20th over 2. Well, now I can do this math because I got same base, different exponents. And I can do this math, same base, different exponents.
Okay, yeah, that makes sense.
So what's my answer?
It'd be 2 to the 9th plus 2 to the 19th.
C. That's an interesting problem. Biggest illustration is that you cannot reduce that. You can't deal with that. Even though it's the same base, different exponents, the fact that you're adding or subtracting, you wouldn't be able to do anything with it. You can multiply same base and you can divide same base, but that's all.
Okay.
All right, M is the median. You know the difference between median, mode, and mean.
Okay.
To figure out all three, what should we do as a first step?
Put them in ascending order.
Okay. Tell me how you would get the, well, okay, what is M?
The middle number, so it would be 40 plus 70 divided by 2.
55. M is mode.
Mode would be 70.
Okay. So what's the average between big M and little m?
60. Nope, wait, it's 125. So 62.5.
Yeah. And you can do that math the normal way, which is to add those two and divide by 2. but you can also try to figure out what number is in between those two numbers. Well, if I look at my possibility, 62.5 is 7.5 away from 70, and it's 7.5 away from 55. Although I prefer the first method. It's quicker, more direct, doesn't require any of that kind of thinking. Okay. So that covered mean, mode, and I can't. Just a second. Verse 14, okay. Let me read the last part of B for you here. Let's see. A is the arithmetic mean of the measures of three angles of an equilateral triangle. B is the arithmetic mean of the measures of three angles of a right triangle.
And those are going to be equal.
Okay. Would they only ask questions like that? We'd be in good shape.
Yeah, I know. Makes me feel smart when they can answer those ones.
Let's see. I need to go to the next page. Oh. Why? Sometimes it's like I used a different camera.
Well, and just to let you know, those recordings are really, really good. I'm really glad that you do that.
Oh, good. Good. I'm glad to hear that because, to be honest with you, I think only about 1 in 10 of my students uses them.
Well, I definitely use them, and it helps me when I go back and sometimes I try to solve the problem, you know, pause it and try to solve the problem and then listen to what you say again.
Oh, good. Good. Yeah.
So I think it's extremely helpful.
Good. I'm sure that they're more helpful to people that are really motivated and trying to learn this stuff as opposed to a typical high school student who's probably trying to get by with as few hours as possible. So I think that's probably why not a lot of but I don't know which ones that use it or don't. So I end up having to go to a lot to put them up every time. So it's nice to hear that somebody does use them. So.
Yes, I do.
Good. Okay, number 14.
Okay, so 10 students took a test and the average was 80. No one scored exactly 80. I don't think this, well, I don't know. We have a total of 800.
Okay.
But anybody could have scored anything.
Right. Yeah, you got to be a little careful with that kind of thinking. That happens to be correct on this problem. But there are limits because nobody can score less than 0. Nobody can score more than 100.
Okay.
And nobody scored exactly 80. Although that may be an irrelevant piece of information, it may not. So the question, in other words, your first inclination is to say we can't tell, right?
Right.
Okay, well, let's just make sure we can come up with two situations where quantity A is bigger and another one where quantity B, or 5. In other words, can we come up with two different situations where one is less than 5 and one is greater than 5? Would it be possible to have a greater than 5? Let's try 6. Yeah, it shouldn't be hard to come up with two numbers that give you an average of 80. I mean, I could, like you said, it can be anywhere from 0 to 79. So I should be able to throw in a couple of 78s there, an average 80. Notice that it is a little bit useful knowing that the average of 80 comes from a 79 combined with an 81. And if I combine a couple of 78s or 77s, in other words, I guess the thinking I'm trying to get you to see is that I'm 6 over my average with these first 6 scores here. So if I get 2 more scores that are 6 under my average, then I'm going to average 80 right there without totaling it up. Because all I needed to know that I was 6 ahead of my average.
And so then you went 6 under.
Yeah. Even though I don't have to do the mathematics, I know that I can do the mathematics. So, yes, I can definitely make this 6. Can I make it 4? Well, easily. 79, 79, 79, 79 combined with 481s. So I can make it 6, I can make it 4. That tells me I cannot determine which is bigger.
Okay.
Now, that probably seemed like a lot of effort to go through when you were pretty sure of your answer, and I would have no problem whatsoever with you going with that gut instinct immediately.
But they're probably going to be expecting people to have that gut instinct and surprise. You know, they'll have one out there where it can be answered.
Yeah, they could make their numbers such that it wouldn't necessarily. In other words, there would be only one possibility. And maybe 5, or maybe a number less than 5, or a number greater than 5. So just be aware that it won't always be able to be any combinations. I can't think of one right offhand, but it seems to me that they certainly are capable of giving you one like that. Okay. Should we do one more? We'll get through 15 again.
Okay.
Which is good. That means we're getting through about 20 of these a session.
And my first inclination is that they're going to be even because x and y will equal 180 degrees.
Okay. Which means that 2x plus 2y divided by 2, which is their arithmetic mean, I can cross that off, and that off, and so I get x plus y, and we know that is equal to 180. So.
Once again, if they can only be that easy, all of them.
Yeah, these data comparison, to me, you may feel differently about that, but to me, this is the easier part of the test.
It is.
Which I find very interesting. Still doesn't make sense to me. No, I mean, what I'm talking about is GMAT has the same problems, only the only difference in GMAT is they have something called data comparison or data sufficiency. And in GMAT, data sufficiency is enough to make you have a headache for a week. They're so hard.
Oh, no.
They are. They're logic problems. And they're like Rubik's Cubes, every one of them, the tough ones. I have an anxiety attack going into GMAT tutoring because those problems are so hard. So here's what I don't get. Why is the test for business school harder than the test for science graduates?
I know that doesn't make sense.
It doesn't make any sense at all.
But I think they figured that with science they're probably going to get everybody on the verbal, but thankfully I read so much that I'm acing that part.
Well, good. Good. Yeah. Now, I did look. Have you thought about the GRE math subject test?
No.
That is 3 times harder than the GMAT test.
Oh.
In other words, if they really want to test your math capabilities through calculus, that subject test for the GRE is brutal. I've been tutoring calculus for 5 years, and I might have problems on that test.
Oh, that's, yeah, not good.
So maybe that's how they, I don't know. I'm still mystified why the GRE is easier than the GMAT.
I'm wondering if they figure it's just because we have calculators anyway in the lab.
Well, you know, they may be a little different now. Since they've allowed use of calculators, they've really changed the test.
Yeah.
As they should. It can't be the same test at all as it used to be, because a lot of the old test was your ability to figure out shortcuts with arithmetic. And that's no longer even a value hardly, because you can use calculators. So I'm sure the test, so the other portions might not be exactly the same. Although if you look at the Kaplan GRE book and the Kaplan GMAT book, they're identical. Not just similar, they're identical except for the sections, the data sufficiency compared to the data comparison. That's the only difference in their two tutorial books. So it's still an interesting question to me. I don't know. Maybe business graduates have to be smarter than science graduates, although that doesn't make any sense to me at all. But anyway, I will, let's see, your next session is Wednesday or Thursday?
Wednesday.
It's Wednesday. Okay. I will talk to you Wednesday morning.
Okay, thanks.
All right, Angela. Bye-bye.
Okay, bye-bye.